Hi everybody, I'm Rob Curtis, and I used to be the Hawaii State entomologist with HDOA, but now I'm a researcher at Washington State University. Today I'm going to be talking about a study that Bob Smith and I did a few years back, trying to track black twig borer damage in coffee. Bob was really the driver of this research because he came up with the methods, collected all the data, and he taught me a lot about black twig borer. He also really opened my eyes up about the importance of this pest. Well, we always start these talks with some background about the pests, but I'll try to keep it brief. Black twig borer was introduced into several places in the US from Southeast Asia. They attack a broad range of host plants in all the places that they're now found, and these beetles are in the group known as ambrosia beetles. And this is because of a symbiotic fungus that they carry in specialized structures on their bodies that are called mycangia. The thing that makes black twig borer unique among the ambrosia beetles is their preference for attacking healthy living plants. Black twig borer was first discovered in Hawaii in 1960, and like in the other places it's been found, it infests a broad range of crop and non-crop hosts. Most of those hosts can tolerate their presence without experiencing significant crop losses. Avocado, for example, creates this white chalky pitch that will push the beetles out of the twigs. However, coffee is particularly vulnerable to black twig borer attack, and it doesn't seem to have any natural defenses. Elsie Bourbano, in her 2010 PhD dissertation, reported that up to 50% of coffee trees surveyed in Kona were infested with black twig borer. But overall, there's been very little research on black twig borer in Hawaii or elsewhere, despite being an important pest. Black twig borer has a complicated type of reproduction. When the females lay unfertilized eggs, those eggs develop into males, while the fertilized eggs develop into females. Within brood chambers, male and female siblings mate, and then the mated females leave to infest new branches. Each female can produce up to 16 eggs, and they're on average in a male to female ratio of 1 to 9. The egg to adult development under ideal conditions takes about 1 month. Several studies have shown that damage in coffee is related to the availability of alternate hosts and inadequate farm sanitation. The foundress female locates a host twig and bores into it to excavate her gallery. And this is the first damage that's done to the twig. At this time, she also introduces an ambrosia fungus that goes on to obstruct water and nutrient flow in that twig. Pretty quickly after entering the twig and introducing the fungus, dieback starts to occur, and you can usually see the impacts right away on the branch. It looks like the picture on this slide within a pretty short period of time. Although they can excavate galleries in both vertical and horizontal branches, woody coffee stems and branches seem to be a little bit more tolerant of infestation. There aren't very good control tactics for black twig borer. The primary tactic is field sanitation, and the recommendation is to prune off infested material 3 to 4 inches below the entry hole and then dispose of those twigs. It isn't recommended to leave them on the farm or on the ground because the adult females that have been mated may then leave the branch and reinfest your trees. There also aren't any insecticides that will penetrate into infested twigs, and no fungicides that will kill the ambrosia fungus. In other parts of the US, there are some sprays that are allowed for non-crop plants to target adult females when they leave the galleries, but they may not be allowed in Hawaii, so I recommend following the labels and consulting with HDOA if you have non-crop host plants that you'd like to treat. We've also observed that the Botanigard that's used for coffee berry borer control also does kill some black twig borer. All right, so that's the quick background for black twig borer. Now I'm going to talk about this study that Bob Smith led on his farm in Kona. Every week from August 2013 through January 2015, Bob sampled visibly black twig borer affected coffee twigs. for the number of larvae, adults, botanic guard killed black twig borer, and also the number of vacated and new galleries. And then I compiled his data into monthly counts and plotted the number per shoot. And here are the monthly data Bob collected from this study. Now don't worry too much about interpreting this figure because I'm going to break it down over the next few slides. All I really want you to take away from this is that from month to month, there's variation in the number per twig for everything that was measured, and that there were always some adults and some larvae found. Now for readability, I don't have any error bars on these figures, but if anyone wants more detail here, I'm happy to provide that information. Okay, so let's start with the adults on this figure. The scale on this figure and the next few is different from the previous slide, and this is so we can look more closely at the month-to-month populations. On the y-axis, we have the number of adults per twig sampled, and on the x-axis is the month and year. Now, the first thing that I'd like to point out about adults is that it looks like there are 2 to 3 peaks per year, and those happen in November and May, and maybe August. And related to this, there are 2 to 3 times per year when the adults decline. And this looks like it happens in September and January, and maybe April. During these peak times, the potential for more damage occurring is higher. And if there were good chemical or biological control tactics available, biopesticide tactics available, then these are around the times when I'd want to target the adults. Larvae have a corresponding pattern of population peaks. On the y-axis in this figure is the number of larvae per twig, and again we have month on the x-axis. Larvae appear to peak in September or October, April, and June, while declines appear in August or September and November. The October and April peaks for larvae are about 1 month before the adult peaks. And it's during these times that I'd recommend concentrating your sanitation efforts because it'll have the biggest impact. Now, comparing adults and larvae, a few things here do make sense. In November, when the number of larvae are decreasing in twigs, the number of adults are increasing. And in January, both larvae and adults decrease in coffee twigs. Again, if there was a good adult control tactic, I'd avoid using it during times when they decline in coffee. And doing more sanitation during the larval peaks before they develop into adults should have more impact in reducing reinfestation from your own farm. The next thing that Bob kept track of was vacated galleries, and the trend here is a little less obvious, but they do appear to increase around December, and this coincides with observed declines in adults in January and larvae in January. Bob also recorded what appeared to be new galleries or those that had just been started, and again, there isn't a really clear trend here, but generally I'd say it looks like there just are always new galleries, but their numbers may go down in September or October. Now, the last thing that Bob looked at was the number of black twig borer that were killed by Botanigard sprays. And the important thing to see here is that there were always some killed by Botanigard, but that it looks like it's more related to population density than anything else. And this means that when there were more adults around, more were killed. And this is most obvious from May through August. And if you recall, adults peaked in May. So their chances of encountering viable spores during this time is increased by their increase in numbers. So I want to tie all this together and summarize our findings. It does look like there are some seasonal patterns to black twig borer damage in coffee, and that populations have 2 to 3 peaks in the number of adults and larvae. However, previous studies have had some slightly conflicting findings on this topic. Elsie Bourbono, in her dissertation, found that all stages were always present and she couldn't distinguish generations. But her and Mark Wright, in one of their papers, also found that populations increased when plants were water stressed during drier seasons. Now this makes sense because stressed plants make easier targets for pests like black twig borer. And I'd say that overall, our findings pretty much agree with their findings. Black twig borer are around pretty much all the time, but there are some predictable population fluctuations through the year. So for this talk, I thought it would be helpful to highlight some of the things that I learned about black twig borer while I was in Hawaii. This pest is really difficult to manage, and as a result, it's also difficult to convince the university and state and federal agencies of its importance. I think some of the reasons why it's difficult to get traction on this pest is that the damage and crop loss aren't really easy to measure. I mean, how do you measure crop loss that happened to your trees 3 years ago? CBB damage, in comparison, is easy to survey. You can see the cherries that have been damaged. But with black twig borer, there may be no cherries to see because the twig died before they developed. Or maybe even the twig died last year or 2 years ago. How do you measure that? I think going forward, black twig borer losses need to be talked about in terms of 3 to 4 year crop cycles rather than just within a single season. Now, because pruning is the only control tactic that's available to coffee farmers, it's never really going to be very effective at managing this pest, because you can't stop them from coming from the environment surrounding the farm. And also, for this reason, a common control tactic that's used against several other pests, which is controlling alternate hosts, probably isn't really viable for black twig borer. We really need new solutions for black twig borer. You need to work together to convince HDOA that black twig borer is important and that the only viable solution may be importation of classical biological control agents. I'd recommend you call HDOA in Honolulu and tell them that the biocontrol branch needs to work on finding agents for black twig borer. Also, call your state representatives and convince them that this pest needs attention. And it's because it's responsible for significant crop and economic losses, and it can't be controlled across landscape scales. I think this insect is a good biological control target because it's not only a major crop pest, but with over 200 hosts, it's also spread throughout the environment. So it can't be managed by any conventional means. So until HDOA takes up this pest as a target, insecticides are needed. So I'd recommend also getting in touch with chemical companies and HDOA to get their help finding something that will work right away. It would be helpful if someone at the University of Hawaii could work out the economics of crop losses caused by black twig borer over the entire growing cycle of coffee from stump to stump or prune to prune, depending on which management style you use. I think losses are compounded every year, but they've never really been measured that way. But when you lose a twig on first year growth, that twig is never going to produce coffee again. And you not only use that year's production, but every year after that would have come off of that twig. If someone could document this information, I think it would be really helpful in convincing state and federal agencies of black twig borer's importance as an economic pest. I think there are also some basic research questions that could be answered to be helpful in management, but the researchers need funding to investigate black twig borer phenology, control tactics, host preferences, and vulnerabilities. And you could help by reaching out to your federal and state representatives to implore them to direct research funds for black twig borer management throughout Hawaii. Since there are so many hosts, you may find allies from farmers that have other crops that are also vulnerable to black twig borer. The easy next research steps that I'd like to see with black twig borer is a study of their populations in alternate hosts, much like this study. And I'd also like to see someone redoing this study to track losses for 3 to 4 years, basically from stumped trees to stumped trees, or Kona-style pruned trees, on several farms. If we find that the population trends are similar in coffee and other hosts, then I'd say we need a chemical control tactic right away. Because we can monitor populations and we can target these vulnerable times. But if we find that the populations don't match up among different hosts, then until HDOA can bring in a biological control agent, we need something that we can manage alternate hosts as well, when and wherever possible, along with intensive sanitation efforts. Now I'm wrapping this up here, and one of the last things I want to say is that I may have left Hawaii, but I'm still very interested in coming up with solutions for this pest. In my current position, I'm not tied to any single crop, so if my help is needed to get the ball rolling on black twig borer research in Hawaii, I'm happy to be involved. And with that, I'd like to say thank you all for your time and attention. I hope this talk was helpful to you. And if I can be of further help, feel free to reach out at any time. Many of the photos that I used were from Andrea's black twig borer website, unless they're otherwise labeled. And before I take questions, I'd like to ask Bob to take a few minutes to talk about his experiences with black twig borer, both before and since this study was done. Once we do take questions, I hope I can answer everything today after Bob talks, but if anything else comes up, please feel free to send me a message at the email address that's listed here, rcurtis with 2 S's @wsu.edu. Thank you for your time.